Effects of Roads on Wildlife by Emma Ram. The Marshner map, from which this one is based off of, was compiled by F.J. Marshner in 1930, titled The Original Vegetation of Minnesota, and was used from notes made by the U.S. General Land Office Survey from 1920 to 1930. This showed the different land uses. As you can see, Minnesota has a diverse collection of ecoregions ranging from plains to forests. Now, in comparison to the 1930s Marshner map and ecoregion map, most of our land is designated for crops, primarily corn, and development, especially in the southern half of Minnesota. In relation to our growing levels of development in croplands, our tree canopy covers all that has not yet been fully covered by crops. However, since the 1930s, Minnesota's population has grown, and with that the roads have reshaped the land. This map shows that much of Minnesota's land is within 200 meters of the road. Our growth and development was able to happen thanks to the roads lowering friction of distance for trade and travel. Roads have negative impacts on ecosystems. Species movement is one of the negative impacts. Vehicle-generated wind currents can act as a dispersal agent for certain species of plants, sometimes spreading invasive species hundreds of meters. These wind currents can travel for hundreds of meters, transporting seeds or other materials, and can therefore interfere with the photosynthesis and transpiration process. Plant and animal species are also affected. Some use roads to migrate, while others are blocked from movement or become roadkill. These act as dispersal channels for both exotic and native species. New environments can sprout alongside roads as invasive species move from place to place. Roadside habitats can enforce the barrier effect roads already have. This barrier effect can affect plants and animals. Mineral, chemical, and pH disturbances from roads have affected the nearby soil and ecosystems. Large quantities of material are moved alongside roads, creating a steady source of mineral material unique to the local environment that may contribute to subsequent chemical disturbances. Several different elements were found to have increased with greater traffic volume alongside roads. A 2013 study found that proximity to all road types made the soils more alkaline relative to the acidic soil in the adjacent native forests. This can change the native plant type and the ability for native plants to regrow in areas. Often, this also aids in the growth of invasive species because native plants are dying out from changes in pH. Some additional negative effects from roads are habitat loss and fragmentation, wildfires, overhunting, and the addition of more roads being built. Much of the road problems are due to lack of planning. Many people don't think about where roads will be and what will happen to the environment when roads are laid down. While noise is not a physical effect from roads, it is a major effect to the ecosystems around it. Traffic noise is a major factor in reducing animal biodiversity near roads. It is an influential factor in recurring negative impacts on the population of the forest. In a 2015 study, traffic noise levels did not diminish to baseline ambient noises until 165 meters from some roads. Road size and traffic noise are directly related. Many traffic noise changes can be seen changing an animal's behavior based on visual and auditory experiences near roads. Anthropogenic noise is heard very differently than natural animal noise. Road size has a major impact on ecosystems around it. Naturally, as roads get bigger, ecosystems around the road are more affected. Also, what the road is made out of will determine how affected the ecosystem around it is. Asphalt and pavement has a higher effect than dirt and gravel. Based on my findings from the readings previous, my research question is, how does road cover affect different types of Minnesota vegetation based on road density and road type? I will use this model to answer my research question. I will be looking at interstates, highways, and all other roads within Minnesota. Also, I will look at Minnesota's road density. I will use the other roads, interstates, and highways and turn that into distance from pavement. I will compile that with the Marshner map, and that will result in my impact of roads. Bottom of the model, we will look at road line density. From the map, we can see that the Twin Cities has the highest density of roads. Smaller city points can be seen connected to the Twin City area by roads, looking similar to veins connecting to major vessels. While it appears that the Twin Cities is the most affected, the majority of Minnesota is yellow, not green, indicating that roads have altered most of the state overall. Compared to the density level of intersections along the interstates, city dispersal away from the Twin Cities is easy to recognize here, if you look at density and level of interstates and line density together. Next, the model identifies locations of roads, interstates, and highways. The distance here were reclassified in equal intervals and converted on a ramp legend based on proximity. When all of the road line densities are put together, we get distance from pavement. This map shows distance from pavement. Northern Minnesota has the most area of green, indicated as far from pavement. Now, looking again at the Marshner map, it is apparent that the land use has changed dramatically in the 70 to 80 years since the Marshner map. The environmental degradation of Minnesota is easy to recognize. While northeastern Minnesota was spared compared to the rest of the state, having a lot less impact due to roads, impact overall can be seen statewide. When Minnesota is divided into the areas compiled by Marshner, with the range of high and low impact of roads on vegetation, a comprehensive map is made. The negative impacts of road is seen largely in what Marshner had depicted as prairie, originally in pink on the previous slide. Solutions are often hard to come by and easily argued. Some are natural shrub walls that can act as a barrier to the roadside environment from forest environment. These can isolate the interior forest from roadside light and dust as well. Man-made shrub walls could have the similar effect to natural shrub walls. While some argue that the friction of distance would be increased due to the shrub walls, others think that it would help protect the natural species inside. Also, the width of a cleared area around roads should be reduced, and traffic could be consolidated based on vehicles using the road. While this would take a lot of effort and roadside planning, some think that this is the best idea. Also, the forest edge should be maintained to maximize the insulating effect that contrasts the edge effect to maintain the at-risk native plant communities within the forest species. And they will fight against chemical changes and invasive species. Also, to fight traffic noise, some mitigation measures could include the natural or artificial sound barriers, dense vegetation belts along roads, traffic control and speed limit reduction, and the restriction of numbers of vehicles on a road at a time. Thank you for watching. This is my bibliography where I got my data from, or my maps, all of which I made myself.